look at it and decide what it is, how to address the issue, what does the function say, and so on and so forth. Yes, that is my first step. I have to factor the denominator. So the numerator is x minus 1, and the denominator is?
X minus 1, x minus 2.
Good. What do I do next?
Find the holes.
Yes, but first I have to write the restrictions.
X cannot equal 1, positive 1. X cannot equal positive 2.
Excellent, thank you. Only now I can do something.
Get rid of x minus 1.
I got rid of x minus 1, so this is 1 over x minus 2. What happens to the factor that goes away? What is it? Yes, that would be a hole in the graph, which is x equals 1. What will happen to x equals 2 for sure? Vertical asymptote. Perfect. Awesome. Good. This is not good enough, though. I have to show all limits. Limit from the left and right of 1, limit from the left and right of 2, and the limits at infinity. So let's start with the easy part, which is limit of 1 over x minus 2 as x approaches infinity, or negative infinity, doesn't matter. What is the answer?
0.
Very good, which means y equals 0, horizontal asymptote, for sure. Now I have to find two limits, left and right of 1 and left of right of 2. So limit of 1 over x minus 2 as x approaches 1 from the left. Limit of 1 over x minus 2 as x approaches 1 from the right. Similarly, limit 1 over x minus 2 as x approaches 2 from the left. And limit as x approaches 2 from the right from 1 over x minus 2. Which one do we want to start with? It doesn't matter. Let's start with, okay, so what is the limit? As x approaches 1 from the left, from 1 over x minus 2.
-1.
Very good. What about the other one?
-1.
Very good. Can anyone give us the ordered pair that will be a hole in this graph?
1, -1.
Awesome. Indeed. When we get to graph these functions in chapter 4, this is extremely important. Good. Ready? What about this? What happens when we plug in 2? Very good. So then I know this is a vertical asymptote and the answer must be in infinity. So 2 from the left. Give me a number, please, close to 2 from the left.
1.
No, 1 is far. 2 from the left, 1.9. 1.9 minus 2. So what do I write?
-10.
So 2 from the right? That's it. So here's y, this is a VA, and here's y, this is a hole. Is this problem clear? Two more limits, problem 10 and 10a and b, and then the precise definition of the limit. Limit as x approaches infinity from the square of x squared plus 4x plus 1 minus x. What is this? Awesome. Awesome. Which we have no clue what it will come out to be. Very good. Then, what will be our next step?
highest degree.
Careful.
Use the conjugate first.
Very good. The square root of x squared plus 4x plus 1 plus x. The square root of x squared plus 4x plus 1 plus x. Very good. That's our way out. Can anyone give us the top?
X squared plus 4x plus 1 minus x squared.
Awesome. What is the degree at the top? Good. What do I factor out? Once you say 1, it cannot be anything else but.
X.
Very good. Now let's look under the square root. What will I factor out under the square root?
X squared.
Very good. What is left in parentheses?
1 plus 4 over x plus 1 over x squared.
Good. Let's go back to the top. We factor out x.
4 plus 1 over x.
Perfect. I got back to the same situation in which I have to take the square root of x squared. But I have to ask myself something very important before I do anything. Sorry about that. I just got carried away with that square root at the top. Makes no sense. Sorry about that. So this is only 4 plus 1 over x. So I have to ask myself, what is the square root of x squared? And this tells me what to replace it by. The square root of x squared, because x approaches infinity, will be? Very good. So this is the square root of 1 plus. It is plus or minus, but since approaches infinity, it's just plus. 1 over x squared plus x. One more step before I apply the limit operator. Limit as x approaches infinity. I have two terms here, one and the other one. And I'm hoping to pull out what? X. I'm hoping to pull out x. Good. What is left in the denominator after I take out an x?
1 plus 4 over x
Very good.
plus 1 over x squared plus 1.
Do we all see this? Yes? Do we all see this? Okay, now what? That was the whole purpose, to get rid of x. And now I'm ready to apply the limit operator. Or drop it if you want, same thing. The top goes to 4. The bottom goes to? Well, there is a 1 in here and there is a 1 in here. 2. So the limit is 2. What does this mean? When we apply the limit of a function when x approaches infinity, and we get a number. Horizontal asymptote at infinity. Y equals 2, horizontal asymptote at infinity. Are we okay with this? Any questions for me? Okay, let's look at this limit. So this is limit. Do we need more time? I don't want you to have to catch up. Always stop me if you need more time, please. Are we okay? Okay, so limit as x approaches infinity from 1 minus e to the x over 1 plus 2 e to the x. It's a limit, and we want to see what type of limit. What do I have to do? Good. And what do I get? The top goes to? Good. Good. Infinite over infinity or negative infinity over infinity, the sign is not important. It's an indeterminate case. Okay, what would you recommend to do here? Yes, take out. Yes, very good. Factor out e to the x. Awesome. That's the answer. So then, what is left in parentheses?
1 over e to the x.
Perfect.
Minus 1 over e to the, that's a good question. E to the x squared.
So let's try. E to the x times 1 over e to the x is 1. E to the x times what is e to the x?
E to the 0.
E to the x times what is e to the x? Yeah, good. Good. What about the denominator?
1 over e to the x.
Good. I clear these two, and now I drop or apply the limit operator. What do I get at the top? Very good. Negative 1. What do I get in the denominator? 2. So the answer is negative 1/2. What do we conclude about this function? What does this limit tell us? Yes, at infinity. Any questions here? Any questions? Okay, so show that the limit 1 minus 3x divided by 2 as x approaches 1 from either side is negative 1 using the precise definition, or also called epsilon delta. Where is the starting point? What do I need to do?
You need to write the definition
Yes, this is equivalent to,
for any epsilon value greater than 0, there exists a value of delta that is greater than 0, such that
0.
0 is less than x minus 1 is less than delta,
Very good.
and
This will result into the distance between 1 minus 3x over 2 and negative exactly plus 1 less than, that's it. Awesome. You do not have to use the symbols, just do what fits you. I'm fine, but you have to write the definition somehow. Okay. You will not get anything else but a linear function. No one asked about the quadratic function. We can look at the quadratic function. There were some problems in the recommended problems, but I will not put on the test a quadratic function or cubic or any other function but linear. Okay, so where is the starting point?
Show that
That's the second part. But the starting point is here. So the absolute value of 1 minus 3x over 2 plus 1 is less than epsilon. What do I write next? What will be our first step?
apply the absolute value theorem.
No, it's not a product or a ratio yet. It's a sum.
we want to add the 1.
So 1 minus 3x plus 2 over 2 in absolute value less than epsilon.
So now we can apply the absolute value.
Negative 3x plus 3 over 2. Then, now I have to apply the rule, but maybe we want to factor out first. Remember what I'm after. Always keep in mind what I am after. This is what I'm after. This is what I'm looking for on one side. And whatever else on the other, I don't care. But this is what I need on one side. Yes, what is left in parentheses? Very good. Now I have to use the property. I have to show the property of the absolute value. That says the absolute value of, very good, awesome, the absolute value of, very good, over, very good. Now I change the absolute value of negative 3 and the absolute value of 2 into 3, the absolute value of x minus 1 over 2 less than epsilon. And remember what I'm after. I'm after x minus 1 in absolute value on the left-hand side. Less than. What do I multiply both sides to have plain absolute value on the left? 2/3. So 2 epsilon over 3. So then we figured out delta. How? Look here for a moment. By comparison. We compare this to this. So how much is delta? That's it. And in step 2, you just have to show, you just have to write one sentence. Step 2, show that delta equals 2 epsilon over 3 works by reversing the steps from above. That's it. Then I know that you understand that there is a double equivalency, and such a proof requires from left to right and from right to left. The extra credit for 10 points. How can a function fail to be differentiable? When the function
Is
not continuous, or has a cusp or a corner, or a vertical tangent. Vertical tangent. So if it's not continuous, it's not differentiable. But if it is continuous, but it has a cusp, a corner, or a vertical tangent, it's not differentiable at those points. Is that clear? Should I repeat? Should I repeat? Yes. So a function is not differentiable when it's not continuous. And if it is continuous, it cannot have a cusp, corner, and vertical tangent. So a function is not differentiable if it's not continuous. But if it is continuous, it will not be differentiable when it has a cusp, corner, or vertical tangent. How many cases are there? Well, cusp, corner are kind of the same case. Vertical tangent is separate, a second case. And the discontinuous is another case. Explain in detail why the function is not differentiable in each case. Well, it cannot be differentiable when it's not continuous, because it has a tangent here and a tangent here. It's not differentiable when it has a cusp or a corner, because it has a negative tangent here and a positive tangent here. The function, if it's differentiable, it has one tangent at that point. If it has two tangents, it's not differentiable. And it cannot be differentiable when the derivative is undefined. Excuse me. Questions? Yes, please. He's being mean to me. Yes.
So is just drawing that enough, or do we have to?
That's
put
enough.
into-
Yeah, that's enough. That's enough. You're showing two tangents. You're showing two tangents. This is differentiable at this point because it has only one tangent. And this here, the derivative is undefined.
Okay. So I kind of put into words.
Very good. That's fine too. Because here it's undefined because the
Tangent approaches.
yeah, because the derivative will be infinity. And if you remember, the derivative is a limit. If the limit is infinity, the derivative doesn't exist. Right? So we know that f prime of x is the limit of a difference quotient. If this is infinity, the derivative does not exist at that point. If it's a limit, it has to be a number or a function. If this is a at a value of the limit, let's say when x approaches a of the difference quotient, if I get infinity, then the derivative does not exist at a. And the function is not differentiable at a. Okay. Is there any type of problem that you would say, if I see it on the test, I'm not so sure. I may or may not be able to solve it correctly. Any type.
Squeeze theorem.
Which one?
Squeeze theorem.
Squeeze theorem. Okay, so let's look at another squeeze theorem. Okay, and also I would like you to go through these limits at least one more time. Only pages 1 and 2. Pages 1 and 2. Okay, so we covered everything, but just in case. Okay, so let's look at another example with the squeeze theorem. And I'm looking at the end of chapter 2. There are plenty of examples there. Let's see if we, yes. So you choose either 23 or 24. So 23 or 24?
24.
Okay, 24 it is. So problem 24 on page 167. So we are asked to find the limit as x approaches 0 from either side from x squared times cosine 1 over x squared. So I plug it in, I know that this approaches 0, and then this is cosine of undefined. 1 over 0 is undefined, cosine of undefined, I have no idea. Where is my starting point?
I'm going to show that cosine is
A bounded, yes. I know that it's a bounded function, perfect. So that's my starting point. Then, step 2. Very good. I'll multiply everything by x squared, but two things I have to be careful. This has to be a positive number, so because otherwise I will have to, I don't know when to switch the inequality symbols. And it cannot be 0. First of all, let's analyze this. Can x be 0?
It can, but only because it's
It cannot. It cannot. So x approaches 0, we really mean it. X is not 0, right? Good. So this is clear. But now, is x squared always positive?
Yes.
Yes, x squared is always positive no matter what x. So our operation of multiplying all three sides by x squared is legitimate because I'm multiplying by a positive number, and that positive number will never be 0 also. So then I have negative x squared less than or equal to x squared cosine 1 over x squared less than or equal to x squared. And this is the first hypothesis of the squeeze theorem. I showed that the given function is squeezed between f of x and squeezed between g of x near 0. Now in step 2.
Let me pick the 1 and negative 1 because cosine only goes between those.
Yes, if I don't have a bound, I won't be able to do this.
So
That's why, yes, that's another indication, basically sine and cosine.
Okay.
Unless I'm given already this hypothesis and I'm asked to find the limit of a function that I don't even have, which we did in class sometime. Okay, so then what will be my next step?
I'm going to find the limit of f of x and g of x.
Very good. What is the limit of f when x approaches 0 from either side?
0.
Very good. What is the limit of g as x approaches 0 from either side?
It's also
Good. So now from 1 and 2, from 1 and 2, by the squeeze theorem, what do I conclude?
Limit of cosine over x squared is
The limit of x squared, the middle one, cosine 1 over x squared as x approaches 0 from either side must be,
0.
that's it. Because the function is squeezed between two functions, and the limits of those functions exist, and they are the same, and they equal 0. Is this clear? Better?
Yeah, for some reason in my head I was thinking that you had 3 pre-existing, like FG and H, and you had to find the one or something.
Okay, is this better now?
Yes.
Good. So we show that this function is squeezed, and the limits of these two exist, and they must be the same, and they are the same in this case. And then from this and this, by squeeze theorem, we know that the limit must be 0. Because if it's squeezed and the top and bottom go to 0, then the squeezed function has to go to 0. Okay, anything else? Is there any other type of problem, limit or otherwise? Anything that you can think of? Any type of problem that you think that we should practice?
More intermediate value theorem.
Okay, so let's look at the intermediate value theorem.
But this is the term, and so I get a little confused. It'll have like f of the leftward bound of the interval, and is less than 10, and then is less than the rightward bound.
But that is not the intermediate value theorem, it's probably this.
No, it's wait. Trying to find the
Are we okay with sketching the graph of an example of a function f that satisfies all the given conditions? Is that okay? Okay. So Tom, did you find it?
almost. It's in here.
Okay, let me do problem 2 on page 167. Sketch the graph of an example of a function f that satisfies all the given conditions. Till you find that, okay? X approaches negative infinity from f of x. That's -2. Limit of f of x as x approaches infinity is 0. Limit as x approaches -3 from f of x is infinity. Limit as x approaches 3 from the left of f of x equals -infinity. And last one, limit as x approaches 3 from the right of f of x is 2. F is continuous from the right at 3. Continuous from the right at 3. Can anyone give us the definition of continuity from the right? I want to write it before we even look at anything. Can anyone give us the definition of continuity from the right of 3?
The limit as x approaches 3 from the right equals f of 3.
Very important. So this is continuity. Thank you so much. Continuity from the right. Please remember this, please. Good. So now I'm going to organize all my information so I can make sense of it. Step by step, I'm going to put them in this table. Tom, did you find it?
Yeah,
Let me write down what it is so we don't forget.
I think I just got confused because it instead of using roots or like 0 trying to find the root of the function, it just has this value n, which basically can.
This is what we did with 1,000.
Right.
So which problem is it?
It's not a problem, just more.
Explanation?
Yeah. Just
Okay, I'll look at it. What page is it?
125.
At the bottom.
Yeah, it just
Very
says let n be any number between f of a and f of b.
Yeah, it's the same thing. So we can create another function that is f minus that number. Yes, I went directly to, if you look at the checklist, I showed you that general definition, but I went ahead to the application. Very good point. This is in continuity, must be in 2.4. 2.5, yes. See, I wrote here for you also the same definition. However, f of c equals 1,000, right? Show that f of c is 1,000. That's your n. So we created the function g, which is f of c minus n. And that's the application that we've been looking at because that's the easiest thing to do to discuss when it changes sign versus where it is between 5 and 6 on the y-axis. So it's better to say, okay, it's negative pi. I bring it down with another function. It's negative and positive. That's much easier than say it's between 5 and 6.
No, I get it. Yeah.
It's the same definition, but I just used the application. I went to the application there. Very good point. Thank you. Okay, so we are summarizing the information. Limit of f of x as x approaches negative infinity. Here's negative infinity is negative 2. So this is done. The limit of f of x as x approaches infinity is 0. So one more time I have to write here, y equals negative 2 is a horizontal asymptote. At infinity, I have 0. Y equals 0 is a horizontal asymptote. So that's my second piece of information. Right? It was 0. Yes, 0. Good. Limit of f of x as x approaches negative 3 from either side is infinity. Negative 3, either side is infinity. Yes, x equals negative 3 is a VA. So this is done. Then limit of f of x as x approaches 3 from the left. Not negative 3, that's 3. So 3 is here. 3 from the left, negative infinity. Limit of f of x as x approaches 3 from the right is 2. And continues from the right at 3. So the limit from the right and the function value are both the same. Ready? When I graph a function with asymptotes, I have to graph the asymptotes first. So here they are. At negative infinity, negative 2.
You slide the
I'm sorry?
points. Yeah, that's it. Just slide.
Sorry. At negative 3 is a vertical asymptote. Both left and right are positive infinity. And on the left-hand side, this is a horizontal asymptote. One, two, three. Infinity on the right-hand side of negative 3, negative infinity on the left-hand side of 3. 3 comma 2 and approaching 0. Obviously, it's a piecewise defined function. This is impossible on the left-hand side unless it's a piecewise defined function. Now you can continue this because it doesn't matter. It's only on the left-hand side. And here is the horizontal asymptote y equals 0. So this is an example. I'm sure you can come up with something else. One more time, I'm checking everything. Horizontal asymptote at negative 2, yes. Left and right at negative 3, positive infinity. On the left-hand side of 3, approaches negative infinity. Then 3 comma 2 must be a point. 3 comma 2 is the, the limit on the right-hand side is 2. And approaching the horizontal asymptote towards infinity. Very good. Anything else? Anything else? Are we ready for this test? Okay, but you still have the entire weekend, right? Okay. So is there anything else? Remember the definition of continuity at the point. Don't forget to go through with a fine comb on all these problems again. I will post solutions tonight, and also the previous test. And I'm hoping that you can browse through the problems we did in class, and don't forget the first 2 pages of this. Okay. Now, I do have about 10 minutes, and if you don't have questions, I'd like to start Chapter 3. Chapter 3 is not going to be on the test on Tuesday, of course. But there is nothing basically new in what I'm going to do tonight in 3.1. Is there anything else? Okay. Differentiation. Rules. Chapter 3. I send my copies for the checklist for Chapter 3, so I will give them to you on Tuesday. Okay. This is very light, just 10 minutes, I promise. Okay. We do remember what the square root of x prime is. We have to commit this to memory. What was it?
1.
Yes?
2x.
2 the square root of x. Good. Good. This is just a refresher. This is one rule that we have to remember. I didn't even say it to you. It's a rule. We have to remember it. Other than, please commit it to memory. Okay. Now let's discuss a function that is x squared. I'm not going to torture you a lot longer with the definition of the derivative because we are going to be using the differentiation rules. But for now, I'd like to use the derivative as a function. The derivative, the definition of the derivative as a function for this particular function. What will you say? True. but just the definition for now. You're correct. This is a refresher for Tuesday.
Plus h.
If I start with x plus
The
h,
limit.
age approaches 0 from
Now
minus.
square.
Good. So let's see what we get. Limit as age approaches 0.
So x squared plus 2x plus h squared minus x squared raised.
Good. Awesome. We've been doing this for a month, right? Good. And we know what has to happen when I calculate the difference quotient. Two things must happen. What is the first thing? All terms without age must go away, and they did. And then eventually this age must go away, because it's the problem. It's what gives us 0 over 0. So then we have limit as age approaches 0 from what? Yes. So we factor out age and we simplify plus age. Now I can drop the limit operator. 2x age over age is 2x. Age squared over age is age. So I drop or I apply the limit. What do I get? That's it. So this is another rule. This is called the power rule. Let's write it in general now. X to the nth power prime. N, we bring n in front, we copy x, and we subtract 1 from the power. So if I want to differentiate x to the 7th power, or find the derivative of x to the 7th power, what will I write? That's it. That's it. So I just want to show you a couple of examples, and then I'll show you one more function, and I'll stop. Let's say problem 14 on page 181. Y equals x to 5/3 minus x to 2/3. So y prime, or if you remember, f prime of x, or dy over dx. These are the notations that we will be using interchangeably in this class. So they're all the same. The derivative of y with respect to x. It's at the end of the checklist. If you go back to the checklist, I put all those notations, but we are only going to use the first 3 on the very last page. So f prime, y prime, dy over dx. The rest are the same, but we're not going to use them in this book. Or this book. Good. So bring down 5/3 times x to which power? 5 over 3 minus 1. 5 over 3 minus 3 over 3. Very good. Awesome. Minus 2/3 x2, 2 over 3 minus 1, or 2 over 3 minus 3 over 3. Good. So now, is there anything we can do to factor this? This is important for chapter 4, to be able to factor. Not important right this moment, but it's important for moving forward. Is there a common factor in the numbers, first of all? 1/3, right? 5 over 3 and 2 over 3 have 1 over 3 in common. Good. Now, is x in common? Do these two terms have x? If they have x, I have to pull x out. But remember, don't look at this for a moment. If I have x to the 4th minus x squared, do I factor out x to the 4th, or do I factor out x squared? The smallest power. So I'm going to come back and ask you, Which of these two is the smallest? Right, so that's x to negative 1/3. Let's see what is left in parentheses. 5 is left in front, correct? From 2/3, careful here, look here for a moment. From 2/3, I subtract the power that I put in front. Exactly, so I have x. Minus, from 2/3, I took 1/3 in front. What is left? 2. And x to negative 1/3 is already in front. So really the simplified form of the derivative is 5x minus 2 over 3 times the cube root of x. This is the fully simplified form. I just want to show one little thing and we're done. I would like to determine the derivative of e to the x using the definition. Can anyone give us e to the x prime using the definition?
The limit
Thank you.
as h approaches 0
Very good.
of e to the x plus h
Very good.
minus e to the x
Very good.
over h.
Awesome. Now, what does this mean? Is there another way of writing this? Okay, if I say to you e to n plus m, what am I really telling you? E to n, not plus, very good, times e to m, right? Copy the base, add the exponents. Okay, so is there another way of writing that? Awesome. Now look at the terms at the top and say you can what? Very good. I will factor out e to the x. And here's what I have left. This is a function that does not depend on h. It's like a constant. I'm going to put it in front. Limit as h approaches 0, e to the h minus 1 over h. I like to put this in the graphing calculator, and I want you to give me the limit. So let's go to y equals, clear, and I put parentheses for the top, e to the x, I don't have h in the calculator, minus 1 divided by x. So this is e to the h minus 1 over e to the h minus 1 over h. And now I calculate the limit close to what? Very good. Second and table. And I'm going to put 0.1, 0.00001, 0.0000001. On the other side, minus 0.00001. So I will show you later a much more elegant way. What does this equal to? So what is the derivative of e to the x? E to the x. E to the x prime is e to the x. You're not going to see this again.